Alright, not very many calculator problems in this unit. That was it. So now we want to write a function where the following is all true and then sketch its graph. So the limit as x approaches 4 of this function is infinity, which means we need to have a vertical asymptote shooting us off to infinity, but the multiplicity on that asymptote has to be even so that the tails are both going together up to positive infinity. So I need a factor of x minus 4 in the bottom squared, shooting us up to positive infinity. Now we want the limit, we want f of 2 to not exist, but we want the limit to exist. You can handle that in two ways. You could, again, do another multiplicity 2 asymptote in the bottom. Or what I'm going to do is I'm going to create a hole at the x value of 2, so x minus 2, like that. So put a factor in the bottom as well. And there you have it. And now it says the limit of f of x as x approaches infinity is 5. It wants a horizontal asymptote at 5. So, again, a couple ways you could handle this. One way is make the degrees the same in the numerator and the denominator. And if we do that, I could put an x squared there. Now it's a cubic in the top, a cubic in the bottom. Now the horizontal asymptote would be at 1, and I want it at 5, so put a multiple of 5 in front, and there you have it. We could sketch this. Boom, boom. X minus 4. We know we have a 1, 2, 3, 4 vertical asymptote right there. Notice that x squared in the top is giving us a 0 right there. That's going to bounce. The 5 is giving us a horizontal asymptote up at the y value of 5. X minus 2, we have a hole, and now we need to sketch this. So it's got to be up like that because I don't have any zeros there. And the multiplicity on that asymptote is even, so this tail also has to be up. So I have to come down, bounce at that, and then go up and approach that asymptote, and it'll look something like that. Okay, let's do another one, though. Another way we could do this. Let's do the same thing. We need the limit to be infinity at x equals 4. So I still have to have a factor of x minus 4 squared in the bottom. But f of 2, limit, f of 2 does not exist, but the limit does exist. Well, if I wanted to, I could do that in the same way. I could say x minus 2 squared like that. That would make my limit exist, but the function is not defined there. And if I wanted to then have a horizontal asymptote at 5, currently that horizontal asymptote would be at 0, but look, I could just add 5 to it like that to shift everything up, so that could be my function right there. And then maybe let's graph this thing and see what it looks like. Well, we know we have asymptotes at 1, 2, 3, 4, positive 4, and positive 2. We've shifted it up to a y value of 5, so we're going to have a horizontal asymptote there. And then everything's just going to be all happy and up, like that. It all has to be up because everything's squared, so there's no way to make this fraction negative. So there you go. It's all up, and we good.